Hello everyone. I hope you're doing well and welcome back to the Math Chaos. For today, we have this exercise. Consider the sequence fn of x equal to n times x to the 1 over n power minus 1, such that x is in the interval 0, 1, n equal to 1, 2, 3, 4, and so on. We have to prove that this sequence converges pointwise to a function f of x in the interval 0, 1. Then we have to find this function when it converges. Okay, first let me change here the letter. Okay, let x in the interval 0, 1, okay, be fixed. Okay, with this or having this, we can calculate the limit, the following limit that will help us to find the limit when it converges. Then here is this limit when n approaches to infinite of the function n times x to the 1 over n power minus 1. Okay, excellent. Then here we will evaluate this limit. Then we will have um, infinite times. Okay, here we have 1 over 1. And if we evaluate, it is 1 over infinite. Yeah, it approaches to 0. X to a 0 power. As you can see, x is fixed. Then it implies that this is equal to 1. X to a 0 equals to 1. 1 minus 1, it's 0. But, here we have problems. It's an indeterminate form. Then here can we use L'Hopital form to find this limit? The answer is not, because we have, or for this condition, we have to complete this one condition. This condition is 0 over 0 or infinite over infinite. Then we have to rewrite this limit. Then let me write it better here. Here we have the limit again of, here we have fraction x to the 1 over n power minus 1, yeah, over 1 over n when n approaches to infinite. Okay, then let me fix this. Okay, excellent. Okay, then we will try again. As you can see here, we rewrite this function, and they are the same. Okay, you can use the extremes and middle rule in fractions, and you can see that they are the same. Okay, excellent. So then here we will uh, we will calculate this. Then here we have 1 over n, 1 over infinite. It's 0, yeah, or it approaches to 0. X to the 0 power, it's equal to 1. 1 minus 1, 0. Over, here we have 1 over n. 1 over n, it approaches to infinite. It approaches to 0. Why? Because n approaches to infinite. 1 over infinite, 0. Here we have another indeterminate way, form. Here I will write it. Oh, okay. But what happened here? Here we can use L'Hopital. Yeah? Then we will find the derivative in numerator and denominator of this. Then here we will calculate it. If we use L'Hopital, then let me write it here. We will divide this part. Okay. Excellent. Here. Okay. Using the L'Hopital, we will have this limit. The derivative of 1 over n is negative n to the negative 2 power. Okay, here when n approaches to infinite. Okay, excellent. And here, this derivative, it is ln of x, yeah, times ln of x times x to the 1 over m power, yeah, okay, times negative, let me write it here, negative n to the negative 2 power. Oh, okay, excellent. Here we have it. And how we did this? And we use chain rule. Yeah, if you want to, you can type to me in the comments. I will do this derivative. Okay, a step by step. Okay, excellent. Here we have it. Oh, here we. Okay. Okay, excellent. Then what we have here? Here we have that we can cancel or we can simplify this, and after that we will have or we will evaluate this limit, and then 1 over infinite, or it approaches to 0, x to the 0 power it's equals to 1 times ln of x, and 1 times ln of x is equal to ln of x. Then what we did here, we found the function, the function that this sequence approaches. It is equal to ln of x. Hello, hello again. I hope you're doing well. Okay, in the previous part, we were finding the function where this sequence approaches. Here, I want to show you what's happening when we assign values on n. Here is the first function when n is equal to 1, uh, and here, so on, when n is equal to 2, to 3, to 4, to 5. They are the functions that we have over there. Obviously, here we are interested in the interval 0, 1, but okay. Then, as you can see here, we approaches and approaches and approaches. Yeah, here we have, for example, when n is equal to n, when to n is equal to 100. So sorry. Here, when n is equal to million, here we have it. Yeah, it's the very last one. Yeah, and as we can see, the value of n grows and grows and grows and grows. When it happens, it approaches to ln of x, as you can see here. This is what's happening in geometric way. So interesting. Okay, excellent. I hope you like this video. And remember that if you have any questions, you can type to me in the comments. I will try to answer. And I guess no more.